Here's my Lego Technic 4-digit mechanical calculator, TECHNIVAC 2. So it's a very complicated mechanism here. An overview here. So the basic working principle I'll try to explain right now. So these motors here, they do drive stuff up here, but we're going to ignore that for now. So it drives down here. It has a fairly strong but still smooth clutch, unlike the new Lego linear clutch parts. So then it drives down here, which then drives all these bevel gears to run all the, so that each of these driving rings will engage, and all will rotate the same direction. So, and then we also have this here, so it's a bit of a limiter, only allows it to rotate one rotation, but because this black part here is free to move, it's a slightly greater amount than a fixed stop would be. So then we've got these dials here with the beams or whatever fixed at approximately 1/10 of a rotation. So then up here we have all these sets of buttons which can all be pressed. They do a few things. So when it is pressed, you can see this thing goes, which moves the lever to engage the driving ring for this unit's place. This one here works the same all the way down the line. Just some of them are inverted because of the way the driving rings are set up. But anyway, so the button press, first it engages it. But if you look down here, you can see that it also is going to block it. So it starts up rotating this, and then when it's reached the position that corresponds to this button, which in this case is the 5 button, it will stop. Then moving on, we now have these freewheels here. So the idea with that is that we can punch in our first number and rotate that axle a certain amount. But then, before we add our second number, if we just add it right away, if we pressed another 5, it wouldn't do anything at all. So first we have to reset this. This needs to go back to 0, and so it can skip over this here without affecting anything. Now the way that we reset it to 0, we electronically, I'll get to that later, reverse the direction of the drive motors. So that does two things. It runs these all backwards, obviously, and so it would try to reset it, each one, but the driving rings aren't engaged. So what it actually does, we've got a direction-sensitive gearbox here, so if it rotates one way, the worm gear slides and engages the 24-tooth gear, which then rotates that, those black parts, and that part, which sequentially push down each of these here to engage each one of these in turn. So it'll engage this one first, it'll rotate backwards until it reaches the stop, and then the clutch gear will slip, and then this one, and then this one, and then this one. If it engaged all at once, it would only run until the first one hit the stop, and then the clutch gear would slip and the rest wouldn't work, so that's why the sequential mechanism has to be that way. So then, after these, we get to our carrying mechanism. So this, basically each of these gears, the amount of degrees it has rotated represents the numeric value that we punched in, but we know that if we punch in a 9 on, well, yeah, this one here, the unit's place. If we punch in a 9 here, then we reset it and punch in a 3, we're not going to have 2, that's what the dial will read. We should have 12, so it has to be able to carry over to the tens place over here. So I'm using this, maybe I'm not pronouncing it right, sautoir, I think, mechanism. I've pretty well taken this design straight from Nico 71's mechanical calculator, so thanks to that. So it moves these red teeth up slowly so it doesn't overstress the motor at any given point. Then when it reaches this point, that goes down and forces this black gear here to rotate 2 teeth, hopefully, which is 1/10 of a rotation. So it pulls up and pops down. And if you want to see that action from the top, that's how it works. So then, after that's happened, well, we've got these ratchets here to prevent it from rotating backwards. Like, when we do this, if it weren't for that, maybe it would go backwards, or it might cause problems with the sautoirs. But anyways, these 22 gears, you can see they drive that 16-tooth gear right in the center, which then drives more 22s. So that's actually a reversing gearbox. So if we slide that 16-tooth gear, it reverses it. And there's one of those for each place. So you can see we got these driving rings here hooked up to levers. The driving rings aren't actually meshing with gears. All they do is slide the axle they're on, which in turn moves the 16-tooth gears to engage the reverse gear. I didn't use a driving ring based gearbox because I didn't want that much backlash would be catastrophic. So I just used them because it's a convenient way to slide an axle. So, we've got the whole axle here with all these switches to control them all at once. So then the drive gets transferred up to these 22 gears, those 4 tan ones you can see on the top. And then each of those runs down to one of these dials. They actually have 2 sets of numbers written on them. If you look up here, you can see we've got, down here we have 4, 3, 2, 1, and so on, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way around the back. But over here we have complements, so where it's 3, they're the 7, where they're the 4, they're the 6. The key thing is the 2 always add up to 10. And because this is the thousands place dial, I've added a negative to all of these. So the only reason we have the 2 sets is because negative numbers can be engaged. So if this is at, say this one is at 1, and then we rotate it the other way 3 because we've reversed the gearbox by hitting the reverse button, it would rotate back to 1, back to 0, and then it would rotate to 9. Now, 2 minus 3 is not 9, it's negative 1. So if the number goes negative, one must rotate this lever here to, so I guess here we've got the 2 there. If we rotate it, now we have an 8, and we also have a negative sign up there, so negative 8. That would be more of a different example if we had, say, 0, yeah, well, say 2 minus 10. 2 minus 10 on the dial, it would rotate this backwards, a full rotation, which would give us a 2. That's not the correct answer. You'd have to slide it and get your negative 8. So I also have a mechanism. Originally it was going to be automatic to slide this thing, but I wasn't really able to make that work in practice. So I'll show you that next. So because I couldn't make it automatic, I made it essentially manual. So you'll notice we have 4 holes here, and the idea is if orange is visible through all 4 of them, that's an indication to the operator that he needs to slide this to reveal the other number. So the theory behind that, so this here is the thousands place dial. Here we go. So this black 3L beam corresponds to the 0 position on the dial, and so on down the line. So right now I believe they're all at 0. So this one, and this one, the thousands, hundreds, and tens places are all showing orange, but the units are not because they don't have that black beam on here. So in this case, it is not negative, but I'm going to have to reverse the gearbox to allow this to work. But if the ones goes past 0, so it's 0 there, but it's rotating backwards right now, so this dark gray here bumps that up nice and high, and causes us to see orange in all four. So that's an indication that because it's 0, 0, 0, and then subtract a negative unit, the total is going to be negative. So then if we, let's move back down here a bit. So if we say that, well, so let's put the unit can be anywhere at this point, and say the thousands, where did this come from? No idea. Hopefully it's not important. So let's say the hundreds and thousands are both at 0. So, but not the tens. So we've got orange, orange. This is not supposed to be showing at all. So then if the tens place reverses itself past 0, it bumps up not only itself, but also the units place, because if we have any number in the units place, if we have a 9, and then we subtract even a 1 from the tens place, even a 10, assuming these two are at 0, we will have a -1, and the total will be negative, and the switch needs to be flipped. So it works essentially the same down the line. If we have, these two can be in any position, but if as long as this one is in 0, and the hundreds goes past 0, they will all be bumped up, and the total is negative. And finally, no matter what the circumstances are, if the thousands place goes backwards past 0, it will bump them all up, and we will have a negative number. So, originally I had hoped that I could hook up these levers here to essentially ratchets on a rack that would slide along with this. This would be spring-loaded so that when all of these were pushed up, all 4 of these ratchets and racks would be unlocked, and this could slide back. But I really didn't see how I was going to make that work practically. It probably could be done, but it would be pretty challenging. So I made mine this manual design where you have to check all 4 of those. And the last mechanism to show is these buttons around here. So we've got plus, minus, off, on, and AC, or reset. So they're all hooked up to this switch down here. So plus and minus hit that side of these beams, pushing the switch that way, which is reverse. AC also pushes that side and reverses it. On pushes it the other way. So it's spring-loaded, so it normally stays in the on position, but when off is pushed, it pushes that down, and because of that dark gray pin down there, it holds it down. If it's off, you can actually still do all the reverse ones, plus, minus, and AC. But when on is pushed, that undoes the off, and it'll continue running. So the reason that the reversing is done to reset, as I mentioned earlier, just reverses the motors. But the plus and minus also have an extra function. You can see we've got that 5 long beam rotating on the center. That causes it to rotate basically shift from the positive to negative. You can see the red changeover catch in the middle there. That's how that works. So the operating principle, normally you'd press the on button, then you'd punch in your number down here, then you'd press the AC button, or no, you wouldn't press that, sorry. You'd press either plus or minus, which would do 2 things. That would ensure that you've got the right rotation, the right direction. And then second, it also reverses the motors and resets them. So you have to hold that for a bit till it's fully reset. Then you can punch in another number, take a look at the answer, and then press AC to reset it. And then off to turn it off. The last thing I'm going to mention before I show this in operation is this one quirk that I'm finding quite annoying, where my zeros here on the dials, they have to correspond to the position just after the sautoir releases to carry to the next one, otherwise it'll carry at the wrong time. But I've been finding that when I'm doing subtraction, switching the gearbox will essentially make that unsynchronized, so it's pretty annoying. I'm not sure how this could be improved, I don't know, but for now, every time I finish with it, I have to flip it over and slide these gears out so that it, the carry mechanism and the dials are disconnected, and then manually get everything back in order, and then slide the gears back in. So now I'm going to start demonstrating it. So I'm going to be adding 2,101 to 869 for an answer of 2,970. So this one is going to require a carry. So we can turn it on, and start by pushing a 2 up here. So you can see this dial has now rotated to 2. And I'm going to push a 1. This dial has rotated to 1. I'm going to press a 0, which doesn't do anything, reading this at 0. Then I'm going to press one more 1. This dial skipped past it and it went to 2, so it isn't all that accurate, you'll notice. But anyways, now I got to reset, so I'm going to hit AC, which reverses the motors. And just get that to engage there. Now it's resetting each one sequentially. And now that's done. So now I can add my second number, which is going to be 0, leaving that the same. Then 8. There we go. And 6. And 9. So, we have some things happen. The answer should be 2,970. So we got a 2. This one here, what is that? That's between 1 and 0. So I think we had a carry that wasn't supposed to happen there. But then we have our 7. That one there went a bit past and is now at 2. So that's what it's having problems with. It's not that accurate. We're going to try another one, see if we can get a better result. So I've got everything reset now. I'm going to turn it on, and then I'm going to add 8,723 plus 42 equals 8,765. So on, I'm going to go 8. I'm kind of bumping it a little. It's having problems with torque. Anyways, there it's our 8. So then we add 7. And yep, we got 7. Then a 2. And a 3. Oh yeah, that one seems to go past a little. It says 4. Anyways, we're going to hit the plus button up here. And that's gonna, get this 24 tooth engaged. It isn't that happy about it. Anyways, now they're resetting sequentially. So that's been done. Now we're gonna add 42. So 0, 0, 4, and 2. Now the answer should be 8,765. We got an 8 there, 7 there, what was that, 6? This is showing an 8, so it went a bit too far there. And then a 5. We also have an 8 there, so that one also went too far. So the last time I didn't actually show the resetting procedure, so I'm going to do that now. So I'll hit the AC button, same thing happens here, the sequential resetting one by one, there, and then the second thing I gotta do, all these dials are still at random values, so I'm starting in the units place, rotating them till they hit 0 by hand up here, and there. So now we are ready to go again. This time I'm going to try a more complicated one. Not only am I going to be subtracting instead of adding, but it's also going to be a negative number. So if it was inaccurate before, it's probably going to be even worse now, which is really too bad. I'd much prefer if it were more accurate, but I don't know, this thing's hard enough for me, just designing the theory of it. Getting it to work in practice using Lego is, I don't know, it's not a challenge I'm ready to take on now, I don't think, but maybe someday. So anyways, the number that I'm doing now are 7,364 minus 5,252 will equal negative 2,012. Not 2,112, sorry. So the first thing is to turn it on. So I'll punch in a 5. Gotta slide that thing down again. Then a 2. And 5. And a 2. And then I gotta press my negative button. Flip all the switches. I'll get this engaged. So now we can reset them all. And then I can input my second number, which is going to be 7. This is going to be going backwards. Go a little further. I'll bump it with my finger. It should go further. Yeah. So it's not going where it needs to. That's where it's supposed to be. And then a 3. Again, it's going to be rotating backwards. Then a 6. And then a 4. So we had all kind of carrying and nonsense going on. So this is not the correct answer. We're going to have to slide this because it went negative. It's shown that detail happening. But anyways, the answer should be negative 2,112. I've got a negative 3, so it's off by 1. I guess that could be a 1. This here is kind of a 1. That one there is 3 and 4, I guess. So yeah, the accuracy isn't great, but it's not usually more than 1 or 2 off per digit, which is still pretty bad, but something is happening, I guess. Maybe I'll try something like that again and see if I can just show you how this is working. So now to demonstrate the going to negative sensing, I'm going to subtract 5,555. So you can see right now that because the thousands, hundreds, and tens places are all at 0, they're all showing orange, because all that we have to do to make the total a negative is for the units to go below 0. So I believe what's going to happen when I punch in the 5 is that this here is going to get bumped up like this, because it's going past 0, which will then reveal orange in all 4 slots, telling me that I need to flip this switch and make it go negative. I'm going to start it up. And punch in a 5. And I think at least what should have happened there is this bumped up and did that. It certainly wasn't for very long, but maybe if you go back in the video you can find the spot. But anyway, I'm going to subtract a 5 here too. So we see that again, it happened. The 5 there also caused it to happen. And a 5 here doesn't do it, I guess. But, so that's how it works. So then I would know I have to flip this thing to get my answer. It should be minus 5555. It's actually minus 6675 or 6. But still, I was trying to show that that thing there works in principle. Overall, I have mixed feelings about this model, I guess. I'm disappointed how inaccurate it was, and I guess a somewhat crude mechanism I had to use to detect when it becomes a negative number. But on the other hand, it is probably the most complicated mechanism I've ever built, with a crazy amount of little mechanisms here and there within it. So it's pretty interesting that way, and I guess given its complexity, maybe some of its performance problems can be forgiven. I don't know. But I'm happy to have done this. It was a great mechanical challenge, and I enjoyed it a lot.